I think we did on page 84. I think we did 6 and 10. Is that right? And maybe 34. Do you remember?
Yeah, we did 84 for sure.
84. We did 6 and 10.
Yeah, we did
6 and 16. 24.
I don't know if we did 24.
Did we do 24? Didn't do 24. Okay. All right. Well, we'll do 24. So page 84. And then number 24. And this is, you're given f of x is equal to 3x squared minus x. What they want you to do is do f of x plus h minus f of x all over h.
Oh no, we did do this one.
Did we do it?
Yeah.
Yeah.
Yeah, we did.
Okay. And then I think did we do 34? Do you want to do another? Do you want to do another one? I don't know whether 34 is worthwhile to do.
How much is 2 over x plus 5? Right?
That 2 over x plus 5. I mean, do you want to do that one? Do you want to not do it? One way, you either got to have a choice, one way or the other. It can't be, I don't care. Because I don't care means I'm not going to do it. You don't want to do it? How many do not want to do it? How many want to do it? Oh, Troy, Miles, do you really want to do one? Well, don't say we can do one.
I mean, sure, I don't.
Do you need to do one? You need to do it. Would 34 be a good one to do, or would one of the ones back up be a good one? I can do, I don't have to change many things to do 34. Two over x plus 5. Now, what you do is, for this first thing right here, wherever the x appears in that function, you put x plus h, right? So you do of course 2 over, and rather than x plus 5, it would be x plus h plus 5. Now, I could put a bracket around x plus h indicating that it's 4x, but it would be just the same without, right? If there's a minus sign in front of it, I should bracket it, right? Correct? You can't go like this. You got to go, yes, I agree, no, I don't agree.
Yes, I agree.
Okay. Then it's minus f of x is going to be 2 over x plus 5. Is that right? All over h.
Yes, sir.
Do you see this thing here, putting that in place of, you know, the x plus h and so on, gives us this. Everyone good? You good? Now comes the part that is you see this 2 over x plus h plus 5, and then this minus 2 over x plus 5 do not have the same denominator, correct? And the common denominator is x plus h plus 5 times x plus 8, x plus 5. Right? So what you have to do is you have to get a common denominator. So this has to be multiplied by x plus 5, x plus 5, right? You build your denominators. And then this has to be multiplied by what?
X plus 8.
Very good. X, was it John or Coy?
That's correct.
Okay. Plus h plus 5. Does everyone agree? Do you see you get a common denominator? And now that whole thing is over h, correct? Now in that numerator, I can just write x plus h plus 5 times x plus 5 as the common denominator. Correct? And then multiply that 2, this 2 times x plus 5 to get 2x plus 10. And then I got to multiply that 2 and change signs times this thing over here, right? So then I'm going to go a minus 2x minus 2h minus 10. Are you good?
Yeah.
John?
Yeah.
I'm waiting for John to say yeah. He
Good.
said, okay. Everybody else good?
Okay.
Now, do you notice this one? That one are the same, right? Well, this one the same and opposite signs. That's what I should have said. So then my numerator is just 2h, isn't it?
H, not X.
Thank you. 2h,
Negative 2H.
negative 2h. Wow. Saying wow. Okay. Now, the way we got to do that denominator, I'm going to distribute this across this one. So I'm going to go x plus h plus 5 times x plus h plus 5 times the 5. That denominator's miserable. So now we got x squared
Plus 10X.
plus hx plus 5x plus 5x plus 5h plus 25. Is that right?
Yes, sir.
Okay. Minus 2h. X squared. We got hx.
Plus 10X. Plus 5H.
What are you talking about? Oh, okay. I see. Plus hx plus 10x plus 5h plus 25. Ooh. That's just ugly looking thing, isn't it? I don't know that it's worthwhile to go. See, this is x squared plus h plus 10 X plus 5 times H plus 5. I don't know that that gets us any place.
Do you miss something? Is it
Huh?
the total answer?
I don't know. I don't know that it benefited us to go any place beyond doing this. Yeah, that was just this thing simplified. I don't think that thing will factor. Okay. I think this is probably the answer that they're looking in the book. Did that help? Not a thing. You have to substitute in for those values. Do you see that? Do you see how to get this thing here from those three things? That's what's important. Okay. It wasn't highly beneficial to do another problem. More than likely, I'm going to give you problems 21 through probably 31 or something like that. Those other ones get too messy. Miles left. He's doing better in his water than you are. He's not going to be up all night.
Guess you have to race. Got a chug. No.
Okay. So let's do 48. They want you to find and interpret these things. So the first billeted item, notice that it says the cost in cents to produce X cups of Mountain Thunder lemonade in Junior's lemonade stand is C of X is equal to 18X plus 240. Now notice that this is cents. So it's 18 cents times X plus $2.40, right? They're saying for every, if you don't, when you do C of 0, and you plug it into this C of X equals 18X plus 240, then what you get is 18 times 0 plus 240, which is 240. So what is that? That's called what? It's the cost that you incur when you produce nothing. That's fixed cost. You have a lemonade stand, what's your fixed cost? $2.40, and that means probably the sugar that you had to put into your lemonade and the lemonade that you had to do and cups that you had to buy, right? Fixed cost, right? $2.80. Whether you sell 1 cup of lemonade or you sell 30, you got to have that, right? That's what that is. This is fixed cost. Now, can you see that any company, any business would have a fixed cost, right? You sell nothing, you're going to have, you'll have to have the building that you're in, you'll have to have whatever, the machinery that you have to build the product, you'll have to have whatever resources you're going to have to build the product, sitting there, whether you make 1 or you make thousands. That's all fixed cost. Now, the next one says find and interpret this particular thing. Well, this is X, how about X? You see, that's average cost, right? It's the cost of producing X units divided by X units. That's average cost. This is average cost. Okay, just think about this. As you produce more and more cups of lemonade and sell them, what's going to happen to your average cost? It'll decrease, won't it? Because your fixed cost will be spread over more and more units, right? The $2.40 will just keep getting spread over more and more units. Because it's costing you, that 18 cents is how much it costs to make a cup of, added cost for each cup of lemonade, right? So each cup of lemonade is going to cost you 18 cents more, and then that 240 is going to be spread out over more and more cups. So your average cost should do what? Should go down, right? So the C of 10, is that what we have? Is that what we're supposed to be figuring? Is now C of X is 18X plus 240 over X. But what I got to do is I got to put 10 in here and 10 down there, right? So this is 180 plus 240 over 10. So what is that? Is that 420 in the numerator? Over 10. Did I do that right? 42 cents. When you produce 10 cups of lemonade, it's costing you 42 cents on average to produce it. Now then, find and interpret P of 5. Well, that P of X notice the thing says 90 minus 3X. This is the price charged per cup, right? So every cup that you sell, what do? You charge on average 3 cents less, right? So if you sell 1 cup, the way this thing is if you sell 0 cups, you're saying 90 cents. If you sell 1 cup, you're taking 3 cents off. You're selling it for 87 cents. If you sell 2 cups, you're going to sell it for 84 cents, right? 2 times 3, correct? Sell 3 cups, you're going to sell it for 81 cents a cup. It's kind of unrealistic because you don't really know how many cups you're going to sell. It's assuming that, well, you're going to sell, 10 cups. So then you're going to price it at 90 minus 30 cents at 60 cents, and you're going to sell the 10 cups. You could say if you sold it for, if you priced it out at 60 cents, you'd sell 10 cups. That's what this is. So in that sense, you could figure out if you knew how many you were going to sell, you would know what to price it at. Does that make sense, what I'm saying? So P of 5 says you know that you are going to sell 5 cups. So if you're going to sell 5 cups, you will price this at what? 90 minus 15? 75 cents, is that right? Price it at 75 cents, you'll sell 5 cups. And that's more of what it looks like when you're trying to do it. And when you're marketing things, you kind of say, well, you know, I think that I can sell so many cups, and I'm going to price it at this price. But that's always a guess. At Christmas time, they misguess things, don't they? When they have stuff left over at Christmas time, and they have sales on their goods, what have they priced their product?
Reduced.
They priced it too high, didn't they? They have to sell it at reduced price. What happens when they have to give out a whole lot of rain checks? They priced it too low, haven't they? They could have priced it higher and sold fewer of them and made more money, right? Because see that's what companies always are having the difficulty, is how do we price our product? Because you see, if we price our product too high and we build so much expecting to be able to sell it, then what happens is we don't sell it all, so what do we have to do? We have to drop the price way down at a real loss in order to get rid of our inventory, so we don't make money. If we price it too low, we could have charged more and had our revenue higher and made more money. But we have to sell all of this product that people want to buy, and we have to sell it on a rain check, and we're selling it below what our cost of production is. So, I don't know whether that makes any sense to you or not. R of X. R of X is the number of units times the price per unit. So that's the revenue. This is revenue. And then the next bullet point is profit. And the profit is the revenue minus the cost. And then that last bulleted point is profit equals 0. Now what that is, that's the revenue minus the cost of producing the goods equals 0. And that's called break even. This is break even. How many units do you have to sell at what price in order to break even? And you can actually calculate that with this information, because the revenue is X, and P of X, if you notice in this thing, is 90 minus 3X. And then the cost is 18X. So I better put a bracket, 18X plus 240. Now I'm just going to solve it. So I got 90X minus 3X squared minus 18X minus 240. So I'll write that decent. It's a second degree polynomial, so we can find it, right? By factoring, we write it in descending order, minus 3x squared, and then what do we have? 90x minus 18x is plus 72. Is that right?
Yep.
Minus 240. Now what I'm going to do is take a common factor out. And I'm going to take a negative out so I get my leading numerical coefficient to be positive. So I'm going to take a minus 3 out. x squared minus, what is that? 24? And then a plus 80? Did I do that right? Now it says 3 times what is 0? Well, 3 times 0, so this thing right here I want to see where that's a 0. And that will tell me how many units to sell, right? To break even. So if I factor that, so what two numbers times itself, this is x, and this is x. That's a plus, that says same sign, and they both have to be minus, right? What two numbers times itself is 80, whose sum is 24.
4 and 20.
Okay, 4 and 20, so it doesn't make any difference where I put that, right? So then I go x minus x minus 4 equals 0, or x equals 20. X equals 4, or x equals 20. Now that's strange. It says I can break even at two different quantities sold. But this is why you can do it, because what do you price it out at? Well, the P of x is equal to 90 minus 3x, right? So if you want to sell 4, you price it at, that's 90 minus 12, 78. If you price at 78 cents, you'll sell 4 of it, you'll break even. Now, what's the price at 20? 3 times 20, 90 minus 60. If you price it at 30 cents, you'll sell 20 of it, you'll break even there. Right? So this is the price that'll get you 20 and you'll break even. This is the price that you will sell 4 cups of it and you'll break even. That makes sense? So it depends upon whether you want to sell it to a lot of people when you set your lemonade stand up, or if you want to sell it to just a few people. It probably applies to McDonald's and all the fast food stuff, right? They could jack their prices up and sell a lot less of it and maybe make as much money as what they do with the lower price. Okay. Any questions on that? On page 86, I'll do 50. I'm going to do something. I'm going to do 52. This says F minus G of 2. So that's F of 2 minus G of 2. Now what you do there is, you see above they have two functions, F and G, which are just a group of ordered pairs. So F of 2 says that you go to that F function and you go across to those ordered pairs and see where is X2. What is the ordered pair where x is 2? 2 and 4. So f of 2 is 4. So what's g of 2? Is it 1? You see the ordered pair that says 2, x, 2, y is 1? So that's 1. Does that make sense? So then this is 3. You see how it works? So let's look at 58. It says f over g of a minus 1. So it says f of minus 1 over g of minus 1. So what's f of minus 1? So you go to the f function and you go to where what? X is minus 1 and y is what? F is minus 1, what's y? 0, right? On the f function. Now you go to the g function and you go where x is 1, minus 1, excuse me, what's y? Minus 4. So what is 0 divided by minus 4? 0. So f over g of minus 1 is that right there. Just like f minus g of 2 is 3. See how to do them? Pretty simple. You see how to do it, Station? Any questions on those? Okay, the next section there says graphs of functions. So whenever you have a function, like you have f of x equals x plus 3, that's actually this relationship, right? So when you graph things and you do that t thing, you go x, f of x. Because this f of x is actually the y value, right? But this is the way you see it. And then you plot, you plug in like minus 3, minus 2, minus 1, 0, 1, 2, 3. Now that's not a really good method of trying to figure out what the graph looks like, but it's how you do it if you're trying to do graphing. Okay. And that's what they're telling you there. And then they're telling you this, that the next thing is you plot the ordered pair x, f of x. So this would be the x value, that'd be the y, and then this would be minus 3 and whatever that f of x is over there. This over here. Now, whenever you do zeros of a function, and a zero of a function is f of x equals 0. So just to convert that, that's saying y equals 0. What are you finding when you set y equal to 0? You're finding which intercept? X-intercepts, right? So do you see that when you take the function and set it equal to 0, it's the same as doing this, and it's the same thing as doing the x-intercept. Now notice on page 95, they're saying zeros of a function are the solutions of the equation f of x equals 0. In other words, x is 0 is a 0 of f if and only if x comma 0 is an x-intercept of the graph of f of y equals f of x. So all you're finding every time you find a 0 is you just finding the x-intercepts. Then they're going to talk to you a little bit about symmetry. Whenever you're symmetric, if it's symmetric, then what I have to do is that point has got to be over here. And that point right there has got to be over here. Now that's symmetric to the y-axis. Now notice it says if you're symmetric about the y-axis, this particular point right here is what? X is minus 2, y is 3. And this is x is plus 2, y is 3. So they're saying that if you do f of x and you do f of minus x, f of x should equal f of minus x if you're symmetric to the y-axis. Notice that f of 2 is equal to what? 2 as what? 3. That's f of 2, isn't it? What's f of minus 2? 3. Is f of x equal f of minus x?
Yes.
It's symmetric to the y-axis. Now, if it's symmetric to the origin, then that says that what you have is a minus 2 minus 3. So you see that if you do f of minus x, it should equal minus f of x. You see, f of x, when x is 2, is equal to what? 3. When I do f of minus x, f of minus 2, and it's this way, equals a minus 3, that is a minus f of x. These two points are symmetric to the origin. This point and this point is symmetric to the y-axis. When you think of symmetric to the y-axis, you take the y-axis, hold it constant, and rotate that board right around. Falls on itself, right? Symmetric to the origin says this. You rotate it around the y, and then flip it around the x. You see you fall right back down on that graph, don't you? Or you can rotate it around the x, and then rotate it around the y, and it'll fall back. It's a double rotation. You see that? That's an origin. Now there's some things. start out here. Oops. I wanted to do this as the E. Now, from A to B, that blue line is increasing, decreasing, or constant. As you move left to right, the Y values are increasing, decreasing, or constant. Increasing. Do you see that? Your Y values are increasing as you go left to right. So that's an increasing function on A to B. From B to C, is it increasing, decreasing, or constant? Decreasing. C to D, is it, see, as I move from X is here to X is here, from X is here to X is here, right? X is here to X is there. So C to D, what is it? Decreasing, increasing, or constant? As I go from D to E, what's the function? Constant. And then as I go E to F, what is it? Increasing. That's what that is increasing, decreasing, or constant. Where is the maximum, local maximum value? B. This is a local maximum. Where would be a local minimum?
D through G.
Well, there's a whole bunch of them, isn't there? Anything D through E. Notice that if this is the end point, and if this is the beginning point of that blue line, there's no absolute maximum. I guess you'd say the absolute maximum would be this one, right? It's the highest point on the graph.
If you asked us to do the
Right.
minimum for that, would you just use it for anything between D and G, so go 40?
Yeah, there's just a whole range of infinite number of local minimums. All right.